Hello everyone, welcome to Practical Mechanics. I'm Mohsen. This session is about lesson number 3, static, which is about dot product of vectors. Let's see one of the most important definitions in static is the dot product of vectors and its application. Let's consider two vectors A and B as free vectors vector A and vector B. Dot product of these two vectors, we can write it as A dot B. The result is a scalar. It's not vector. It's a number. It's a value. And is equal to magnitude of vector A times magnitude of vector B times the cos of angle between them. Angle between their directions. Makes sense. Okay, because they are free vectors, we can write them from a common tail point. For example, this is vector B, and that's it, vector A. The angle between them, called the theta, angle between their directions. And in this case, it is equal to A, magnitude of A, times magnitude of B, times cosine theta, or cos theta, which is a number, which is a scalar. It's not two vector. Then dot product of two vector is not vector, it's a scalar. That's a definition. And this definition works for us in solving many problems. In solving many problems. For example, one of the first problems that it solves for us, this definition, is the projection of vector on an axis, x or y, for example. Consider the coordinate. X and y, positive y direction, positive x direction, and consider vector A, which is an inch, as a free vector. Just draw a line parallel to A with the same magnitude, vector A, and make the angle. Consider this angle with horizontal axis as you between positive x-axis and between the positive of the vector axis, direction of the axis, vector, and direction of the positive x direction. This angle theta. And you know about the unit vector I and unit vector j. Okay, if I write vector A dot I, it means that magnitude of A cos magnitude of I, let's write it in this way, times cos between them, angle between them, is A times 1 times theta which is what? A cos theta. A cos theta is equal to the projection of this vector onto vector x, or the component of the vector along x-axis. It is equal to what? We called it ax. Ax is the component of A. The magnitude of this projection of the vector along the x-axis. Ax. Then, if you dot product the vector I, unit I, you get its component along x-axis. In the other, A dot J is equal to, again, magnitude of A times magnitude of unit vector J, cos angle between them. You can call this angle alpha. Angle between both sides of them is A times 1 times cos alpha. Is A cos alpha is A y. When you wanted to project a vector onto an axis, consider the angle between the vector and the positive direction of that axis. Angle between this vector and the positive direction of the y. Then it is A cos alpha, A cos theta, because AX and AY. These are scalar. These are the magnitude of the vector components in x and y direction. That is one of the use when then I can write this vector as what? I can write vector AX in I direction plus AY magnitude in J direction. This is called the component writing the vector in terms of its components in x and y directions. Assume that we have two vectors. Assume that we have two vectors. Another vectors like vectors C, free vector. We wanted to find out components of vector C here. Because it is a free vector, we just move it here, 6 inches as vector C. And the angle it makes with x-axis, we called it beta. And the angle that it makes with y-axis, we called it gamma. Okay, we work with these two angles. Alpha and beta and gamma. Okay, then you know Cx, vector Cx is equal to Cx times Cxi. How I can reach to this one? First, vector C dot product I is equal to C dot C cross 1 cross cos beta is C cos beta. This is what? Cx. And vector C, just vector C, sorry, let's correct this writing. Vector C, not magnitude of C. Vector C dot vector I is equal to magnitude of C, magnitude of J, the angle between them is cos alpha. Alpha? No, gamma. This angle between C and Y is gamma. Then this is C times 1 times cos gamma, C cos gamma. We called it what? Component of vector C along Y axis. I can write this vector, let's correct this one. C is equal to Cx I plus Cy j. The form of this vector into its component. Cx and Cy. Then I found that I resolve a vector. I resolve a vector into its component along x and y axis by dot product. Then I have two vectors here. One is this one. The other one is this one. I wanted to find the dot product of these two vectors. Then I do not need this line anymore. I wanted to find dot product of two vectors in terms of the component. This is make it easy for us. I can write a vector A dot vector C is equal to magnitude of A times magnitude of C times the cos of angle between them. Okay? But if I write them in terms of its component in x and y direction, I wanted to find out A dot C is the same as C dot A. No difference. Because the result is a scalar. It's not vector. The order doesn't matter here. You multiply A by C or multiply C by A. No difference. Okay? Then I take this one. I write, instead of A, I write AXI, AYJ. These two represent A, vector A. Dot. Instead of C, I write CXI plus C by J. These two represent vector C. Okay, I expand this. It is this times this and this. Okay? And then what we have? We have AX, CX, I dot I. Two vectors dot products together. These are numbers. Just I multiply numbers like 2, like 3, 2 times 3, 6, for example. Plus this times this one. AX times CY I dot J. These are two vectors and this is the product of them. This is just a number, coefficient, constant, plus this times and this dot this one. Okay, AY times CX J dot I. Okay. And plus AY CY J dot J. You can write them, for example, AX I dot CX I, and because these are two constants, you can take them out from actually this dot production and say ax cx I dot I, right in this format. Okay, what is I dot I? I dot I is the dot product of two unit vectors, means magnitude of the first one times magnitude of the second one times the angle, cos of angle between them. What is the angle between I and the I again? Between I and itself? 0. Cos 0. Angle between them, theta is 0. What is this magnitude? 1 times this 1 times cos 0, 1 is 1. Then I dot I equals 1. Okay. What about I dot J? I dot J equals magnitude of I times magnitude of J times cos of angle between them. What is the angle between I and J? Two unit vector. 90 degrees. 90 degrees angle. Cos 90 degrees equal 1. This is 1. Magnitude of I 1. Magnitude of J 1 times cos of 90 degrees 0. Result is 0. Then I dot J always is 0. I dot J. Here J dot I told you that there is no difference between A dot C or C dot A. J dot I is the same as I dot J. No difference. Magnitude of J dot cross magnitude of I, cos of angle between them. Angle between J and I again is 90 degrees. Then 1, 1, 0, 0. What is J dot J here? J dot J is equal to magnitude of J times magnitude of J again times angle between them. What is the angle between a vector and itself? 0. Then 1 times 1 times 1 is 1. Then I dot product of two vectors is a scalar unit 1. J dot J is also 1. I dot J or J dot I 0. Then let's make this simple. A dot C was equal to this one, and it's equal to, this is AXCX times 1. This is 1. AX 6. This is AXCY times I dot J. I dot J is 0. Then this term is cancelled out. The result is 0. A by CX, J dot I, also like I dot J, is 0, J dot I. Then this will be cancelled out as well, is 0. A by C by J dot J is 1. Then plus AY, CY. Then the result is this, AXX plus AY, CY. What is it? If you dot product two vectors and you write them into component form, rectangular components, orthogonal components of each vector, dot product each other, just you use their products of components that has the same name, AX times CX, AY times CY. And this is a number, this is a number, a scalar, and the result is also a scalar. If I use A dot C. What's the difference between if I use A, vector A dot vector C is equal to magnitude of A, magnitude of C, the cos of angle between them. I know the magnitude maybe, but maybe I don't know the angle between them. But if I decompose them, I resolve them into x and y components, A as ax and ay, C as cx and cy, then I do the dot product, I can write the result without need any angle. That's the reason. Without need any angle. I don't need to measure the angle between them. If I know component in x direction, component in y direction for each one, then x component times together, y components times together, add them together is the result of this dot production. Okay, we use this definition for many applications. One of them is work, that we use in definition of work, actually force, how much the force is aligned the direction of displacement. Direction of displacement, direction of the force maybe are not in the same. They have an angle between them. How much of this force can work? The amount of force that lie in the direction of the displacement. We use dot product here. And we use this dot product also to find out component of a vector, along any axis. It needs that you know the unit vector of that axis. For example, I got an axis which I called it S. Vector S. If I know its unit vector we called it what? ES. Okay. If I wanted to find the component of this vector along this axis, it is enough like that I multiply it, the vector by I to find out its component along x-axis. I dot product the vector on J to find out its component along y-axis. Also, if I dot product the vector with unit vector in S direction, I can find the amount of this vector that is in the S direction. Okay, it is what? Magnitude of A times magnitude of ES times angle between them. Assume cos theta. Angle between positive direction theta. And this is A times 1 times theta is A cos theta. It is the projection actually. Projection of A in S, which is equal to this one or this one. This is the angle here. This angle also is equal to theta. Same angle. Then we called it what? AS. AS. This is AS. The amount of the vector A that in the S alignment can be found out by dot production of vectors. Dot production of this vector times unit vector of S gives us the projection of A along S axis, any directions. That's another application for dot product. Okay, that's what one of the products of two vectors, which we call the dot product. We have another product which is called cross product of two vectors. In static, we need cross product also for definition of moment of a force. And calculation of this moment is by using cross products of vector force and its distance along from any axis. In lesson number 4, we talk about cross product of two vectors. Thank you for watching. See you in the next video, lesson number 4.